Comparison between NPN transistor and PNP transistor. Number 1. In NPN transistor, P-type base is sandwiched by N-type emitter and collector. Longest part of NPN transistor is the collector. This is emitter, base and collector. Emitter is N-type, base is P-type and collector is also N-type. And in this case, conduction electrons are the majority charge carriers in emitter. Holes are the majority charge carriers in p-type base, and these are the conduction electrons. This dot are the conduction electrons, and circled positive sign is are the holes. And in this case, emitter is forward biased by connecting a battery of EMF VEB in emitter base circuit, and in collector base circuit another external battery of EMF VCB is connected for having a reverse biasing of collector with respect to the base. For NPN transistor, emitter current IE flows away from the emitter, and base current IB/IC flow into the base and collector respectively. IE is the emitter current and IB and IC are the base and collector current respectively. Now on the right hand side we can draw a PNP transistor in which N-type base is sandwiched by P-type emitter and collector. We can denote emitter, base and collector terminal, and here base is N-type. Positive sign are the holes which are majority charge carriers in P-type emitter. Similarly, holes, these are the holes in P-type collector. P-type collector. Now we can denote the majority charge carriers of N-type base. Dot means conduction electrons which are the majority charge carriers in N-type base. Now we can connect an external battery VEB for having forward biasing of emitter E, and in this case positive terminal of the external battery is connected to P-type emitter. VEB is the EMF of the external battery which is providing forward biasing of emitter with respect to base. On the right hand side we can connect another strong battery for having a reverse biasing of the collector. VCB is much greater than VEB because collector is reverse biasing which offers very high resistance. That's why the battery of EMF VCB will be a strong battery, and in this case holes in P-type emitter will be migrating into the collector through the N-type base. 95% of holes or majority charge carriers migrating from emitter through base will pass over to collector, P-type collector, and 5% will remain in the base. IE is the emitter current, IB and IC are base and collector current which are flowing away from base and collector respectively, but emitter current IE flows into the P-type emitter. On the left hand side we can denote that conduction electrons, that is majority charge carriers, on 95% of conduction electrons migrating from emitter will pass over to collector through the base, and 5% will remain in the base. The emitter E, that is N-type emitter E for NPN transistor is forward biased with respect to P-type base with respect to the base under bracket B by connecting an external battery, the negative potential or negative pole of the external battery. By connecting the negative pole of the external battery of EMF VEB with respect to n-type emitter. And here n-type emitter is forward biased. N-type emitter is forward biased. By connecting this negative pole of the battery VEB to n-type emitter for having the forward biasing of the emitter with respect to base. On the right hand side, p-type emitter under bracket E is also forward biased with respect to base B by connecting the positive pole of the external battery of EMF VEB to p-type emitter. Emitter E is forward biased with respect to base B by connecting positive pole of the external battery of EMF VEB to the p-type emitter. To the p-type emitter E. On the right hand side here, positive pole of the battery of EMF VEB is connected to p-type emitter so that emitter is forward biased, or for providing forward biasing of p-type emitter. Here p-type emitter is forward biased by connecting positive pole of the battery of VEB with respect to the p-type emitter. The n-type collector, on the left hand side, the n-type collector is reverse biased with respect to the p-type base. The collector C is reverse biased with respect to the base by connecting an external battery of EMF VCB by connecting the external battery, or by connecting the positive terminal of the external battery VCB to the n-type collector. The collector C is reverse biased with respect to the base B by connecting the positive terminal of the external battery of EMF VCB. Now this positive terminal of battery VCB is connected to n-type collector for providing reverse biasing of the collector with respect to base. So here the collector is reverse biased. Similarly, the negative terminal of the battery is connected to p-type collector, so that p-type collector is reverse biased. On the right hand side, for PNP transistor, the p-type collector C is reverse biased with respect to n-type base. The collector C is reverse biased with respect to the base B by connecting the negative pole or negative terminal of the external battery of EMF VCB. The collector C is reverse biased with respect to base by connecting negative terminal of the external battery of EMF VCB to the p-type collector. For NPN transistor, as the collector C is reverse biased with respect to the base by connecting the positive pole of the external battery of EMF VCB to the n-type collector, the collector base junction offers very high resistance. And the EMF VCB of the battery is quite large, which is approximately equal to 45 volt, which is applicable for NPN transistor. On the right hand side, if the collector C is reverse bias with respect to the base by connecting the negative pole of the external battery of EMF VCB to p-type collector. The collector base junction offers very high resistance, and the EMF VCB of the battery is quite large, which is approximately equal to 45 volt. When 95% of conduction electrons migrating from n-type emitter into n-type collector and recombine with the holes in existing in collector current IC will be produced, and remaining 5% of conduction electrons migrating from n-type emitter will remain in p-type base and recombine with the holes, producing base current. Collector current IC flows from collector to base, and base current IB will be flowing from base to emitter. That means on the right hand side, if 90% of migrating holes from p-type emitter pass over to p-type collector current will be produced, and remaining 5% of migrating holes will remain in the base and recombine with the conduction electrons, producing base current IB. 5% of migrating holes coming from p-type emitter will recombine with the conduction electrons in base, and base current IB will be produced. When the conduction electrons which are denoted by dot, that is the majority charge carriers migrating from n-type emitter, when the conduction electrons, that is the majority charge carriers migrating from n-type emitter under bracket capital E, when the conduction electrons, that is majority charge carriers from n-type emitter E, migrate into p-type base under bracket, it should be B, p-type base under bracket B, only few conduction electrons under bracket 5% of migrating conduction electrons from n-type emitter recombine with the holes under bracket majority charge carriers of p-type base under bracket B. P-type base under bracket B, resulting the base current IB such that IB is equal 5% of emitter current IE. Therefore, IB is equal 0.05 times of IE. Base current IB is equal to 0.05 IE, where IE is the emitter current. So, IB is equal 0.05 times of IE. On the right hand side for PNP transistor, when the holes, that is the majority charge carriers from p-type emitter under bracket E migrate into n-type base under bracket B, only few holes under bracket 5% of migrating holes coming from p-type emitter recombine with the conduction electrons under bracket majority charge carriers of n-type base under bracket B, resulting the base current IB, which flows away from n-type base such that IB is equal to 5% of IE, where IE is the emitter current. Therefore, IB will be 0.05 times of IE, which is the base current. And this base current will flow away from the n-type base, and on the left hand side that is also base current. On the right hand side, for PNP transistor, base current IB flows away from n-type base. If we draw this is PNP transistor, and we can denote the majority charge carriers, that is the holes in p-type emitter. Conduction electrons are the majority charge carriers in n-type base. Here this is PNP transistor. We can denote emitter, base and collector terminals. Holes, that is majority charge carriers, will migrate into p-type collector and will remain in the base, producing base current IB, and emitter current will flow into p-type emitter. Emitter current flows into p-type emitter. Base current IB will flow away from n-type base, and on the left hand side, IB is the base current which flows into p-type base. Base current IB for NPN transistor flows into p-type base. On the left hand side, we can consider we can draw NPN transistor. We can denote the majority charge carriers. Dot means conduction electrons in n-type emitter. Dot, these are the conduction electrons, and circle positive sign means holes existing in n-type emitter. And this is p-type base, and p-type base will be sandwiched between n-type emitter and collector. E is the emitter, B is the base, and C is the collector. Holes are the majority charge carriers in p-type base, and conduction electrons are the majority charge carriers. Conduction electrons migrating from n-type emitter into base and collector, producing base current IB and collector current IC. Emitter current flows away from n-type emitter, but base current and collector current will flow into the base. The remaining majority charge carriers, the remaining 95% conduction electrons migrating from n-type emitter, that is the majority charge carriers, that is the 95% of majority charge carriers migrating from n-type emitter, under bracket E, will pass over to n-type collector through the base The remaining 95% conduction electrons migrating from n-type emitter will pass over to n-type collector through p-type base on account of high positive potential of the external battery, or high positive potential of the collector due to the battery VCB, resulting the collector current IC, such that IC is equal 95% of IE, where IE is the emitter current. Therefore, IC is equal 0.95 IE. IC is equal 0.95 times of IE, and IC is the collector current. IC is the collector current which flows into N-type collector, which flows into N-type collector, which flows into N-type collector. Now we can draw the diagram of NPN transistor. NPN transistor. This is NPN transistor. Dot means conduction electrons. We can denote majority charge carriers and minority charge carriers. This is conduction electrons. Dot and circle positive sign means holes. Here remaining 95% of conduction electrons migrating from N-type emitter will pass over to N-type collector, and this 95% of conduction electrons will recombine with the holes existing in N-type collector, producing the collector current IC, and that collector current IC flows into the N-type collector IC. The collector current IC flows into N-type collector, but emitter current IE flows away from N-type emitter. Majority charge carriers, that is holes from P-type emitter, will migrate into P-type collector through N-type base. Here these holes will migrate into N-type base and recombine with the holes and producing base current IB, and remaining 95% of holes will migrate from P-type emitter to P-type collector through base, and this 95% of holes migrating from emitter to collector through base will recombine with the conduction electrons in P-type collector, producing the collector current IC, which flows from base to emitter. The remaining 95% holes, that is the majority charge carriers, migrating from P-type emitter, majority charge carriers migrating from P-type emitter under bracket E will pass over to P-type collector. The remaining 95% holes migrating from P-type emitter will pass over to P-type collector through N-type base, P-type collector under bracket C through N-type base on account of high negative potential of the collector due to the battery. That there is 95% of holes migrating from P-type emitter will pass over to P-type collector on account of high negative potential of collector due to the external battery of EMF VCB, resulting the collector current IC such that IC is equal to 0.95 times of IE, where IE is emitter current, and this collector current flows away from P-type collector. Then we can explain the production of collector current IC and base current IB. This is PNP transistor on the right hand side, and we can denote P-type emitter, N-type base and P-type collector. So this is PNP transistor having three terminals, emitter, base and collector. These are the holes which are majority charge carriers in P-type emitter, and dot means conduction electrons which is minority charge carriers. Plus means holes and dot are conduction electrons existing in P-type emitter. And here we can denote three terminals E, B and C, emitter, base and collector terminals, and majority charge carriers holes will migrate, and 5% of holes or majority charge carriers will migrate into N-type base and recombine with the conduction electrons, producing base current IB, and 95% of holes migrating from emitter to collector will produce collector current IC. Here emitter current will flow into p-type emitter, but base current IB and IC will flow away from base and collector. Now you have to draw the symbol of NPN transistor. This is the base terminal, and two oblique straight lines will be the emitter and collector. This is what emitter. On the right hand side, the oblique straight line is the collector, and this will be the NPN transistor. This will be the NPN transistor. NPN transistor. This is the symbol of NPN transistor. An arrow is indicated on the emitter in this way, so that this arrow is moving away from the transistor. This arrow is indicated on the emitter and also it is indicated at the end of the straight line, and this is the arrow which is indicated on the emitter, n-type emitter. And for NPN transistor, this arrow is moving away from the emitter, and we can connect the external battery for providing forward biasing of emitter with respect to base. This is the external battery, negative and positive pole of the battery, having EMF VEB, and emitter current IE will flow away from the NPN transistor. This is IE, or emitter current. And on the right hand side, we can connect another external battery for providing reverse biasing of the collector. Now we can connect another external battery in collector based circuit. This is the external battery which is connected to collector with respect to base for providing reverse biasing of collector with respect to base. This battery and positive pole of this battery is connected to n-type collector, and negative pole of the battery of EMF VAB is connected to n-type emitter. And here and this is the symbol of NPN transistor. For NPN transistor, collector current IC and base current IB flow into the NPN transistor, and emitter current IE flow away from this transistor. And the arrow on the emitter, the arrow sign on the emitter indicates the direction of emitter current. This arrow sign which is indicated on the emitter indicates the direction of emitter current, under bracket IE. The arrow sign indicates the direction of emitter current IE. In this case, emitter current IE is the sum of base current and collector current. That means IE is equal to IB plus IC. IE is equal to IB plus IC, that is emitter current is the sum of base current and collector current. Where IB is the base current, or IB is equal to 0.05 IE, and IC, which is the collector current, IC is equal to 0.95 times of IE. IB is equal to 0.05 IE and IC is equal to 0.95 IE. Now this base current IB and IC flow into the transistor, and emitter current IE flow away from this NPN transistor, and that's why IE is equal to IB plus IC. Here IB and IC, Here emitter current IE is the cause, and IB and IC, base current IB and collector current IC are the results. That means from the emitter current IE, we get base current IB and collector current IC. On the right hand side, we can draw the symbol of PNP transistor. This is the base, and we can denote this is the base B, and we can denote collector. This terminal is collector, and other oblique terminal is the emitter. This is emitter E, and we can denote an arrow sign on the emitter. This arrow sign is moving into the transistor for PNP transistor. For PNP transistor, this arrow is moving into the transistor, but for NPN transistor, that arrow on the emitter is moving away from the transistor. This is PNP transistor. We can connect an external battery for providing forward biasing of emitter with respect to base. This is the battery, external battery of EMF VEB, and this are the positive and negative terminal. And also you can connect another external battery in collector base circuit for providing reverse biasing of P-type collector. Now negative pole of the battery is connected to P-type collector. Now the arrow sign on the emitter, we can denote the emitter current IE. Emitter current IE flows into the P-type emitter for PNP transistor, and on the other side the collector current IC flow away from the P-type collector. This is the direction of collector current IC, which flows away from P-type collector, and base current IB is also flowing along this direction. That is, base current IB flows away from the N-type base, and this is the symbol of PNP transistor. This is the symbol of PNP transistor. And this arrow sign on the emitter, indicates the direction of emitter current IE also. This arrow sign on the emitter, indicates the direction of emitter current IE. On the right hand side, again this arrow sign indicates the direction of emitter current. Under bracket IE. The arrow sign indicates the direction of emitter current IE. In this case, we can say also that emitter current IE is equal to IB plus IC. In this case, emitter current IE, which flows into the P-type emitter, is equal to IB plus IC. It is the sum of base current IB and collector current IC. We get IE as IB plus IC. That is the emitter current, sum of base current and collector current, where IB is equal to 0.05 into IE. 0.05 into IE, where IC, collector current IC, is equal to 0.95 times of IE. Collector current is 0.95 times of emitter current IE. IE flows into P-type emitter. Collector current IC and base current IB flow away from the collector and base respectively. That's why IE is equal to IB plus IC. That means emitter current is sum of base current and collector current.